Hi, Professor Sills here again, and this is your Chapter 7 overview. So allow me to kind of get right into it. Looking at number 1, primary difference between a cloud droplet and a raindrop. Covered again in early chapters, you're dealing with size. Cloud droplets, think of fog. They are small enough to remain suspended in the atmosphere without falling. Raindrops are 1,000-fold bigger. Number 2, why do typical cloud droplets seldom reach the ground? Because they are small enough to remain suspended. Something fine enough will remain suspended in the atmosphere. Okay, skipping up to number 9. Heavy showers usually fall from cumuliform clouds and steady precipitation from stratiform clouds. Well, cumuliform clouds, as you can see in the image behind me and in front of you, are vertically developed clouds. And there are a couple of things to be aware of. They're small. I mean, they're only a few miles across. A thunderstorm is usually only 1 or 2 cities or parts of a city that'll be affected by it. But since they occur in the summer and since they're vertically developed, they're loaded with moisture. So you're going to get some very heavy showers out of that. Whereas a stratiform cloud, which is a layered cloud, it's a flat cloud covering a much larger area. Stratiform clouds tend not to have as much moisture with them, but they will produce precipitation over a prolonged period of time, usually associated with a weather system like a cyclone. And I showed you a front and an approaching front before using the cyclone software, and we'll see more of that as we get a little further into this over the next few days. Atmospheric conditions for snow when the temperature is considerably above freezing. All right, let's take a look at this. This is how do you get various forms of precipitation? Well, typically, this is the snow profile. It's below freezing at all heights above the ground. This vertical is increasing elevation. So if it's below freezing where the clouds are, snowflakes form, or ice crystals form and aggregate into snowflakes, to be technical. And then the snowflakes fall, and they remain as snowflakes when they hit the ground. If the temperature profile gets above freezing down here, and it's a very shallow layer, if it's, let's say, 500 feet or 1,000 feet from the surface up to where it's below freezing, in other words, it's only the lowest 500 or 1,000 feet that's above freezing, it could still be snow. It'll be a very wet snow because the snow will be partially melted. It's almost like mush falling out of the sky, but it'll still be snow. That's how you get that. Let's just continue on the same theme, and then you can piece it in with the questions as they come up. Now, if you have a sub-freezing layer and then it warms to above freezing and then there's cold air trapped near the ground, you'll end up with sleet. You will not have snow because the snow melts and then refreezes as ice pellets. Very simple. Now, this is something that's very common in New Jersey. Why? Well, just to our east, there is the Atlantic Ocean. And the Atlantic Ocean, even in the winter, well off the coast, you have temperatures as warm, sea surface temperatures as warm as 70 degrees, even in January, in the Gulf Stream. So when you get a big swath of air flowing from the Atlantic into New Jersey, what happens is what we call overrunning. You have cold air sandwiched at the ground. You have warmer air coming in that rides up and over the cold air, creating that inversion that we talked about. But when the warm air rides up and over, that's how you end up with this kind of profile. You end up with above freezing air at 2,000, 3,000, 4,000 feet above the ground. That takes any snow, melts it, and then if there's cold air near the ground, you have sleet, which results from that. Now, if we look further down this page, and by the way, you can go to this page yourself. Let me remove the frame. You can go to oceanservice.noaa.gov and you can copy the rest of the URL. And as I go down this page, if the warm layer is deeper or thicker, compare the warm layer here and the warm layer here. Instead of sub-freezing air at the ground that'll produce sleet, you still have sub-freezing air at the ground here, but it produces what we call freezing rain. Now, freezing rain is probably, as you know, being a resident of New Jersey, one of the nastiest precipitation forms that we ever see, because that's where you get the glaze on everything. Sleet tends to not be quite as slippery, nearly as slippery as freezing rain. Freezing rain is definitely the nastiest of the nastiest. And obviously, if the ground layer, the air near the ground, is above freezing, well, then you're going to have plain old rain. Doesn't matter what's going on above you, you get plain old rain. So let me now go back to the questions and let's see where we are. 17. Sleet versus hail. Understand this. Everything that I just talked about is from stratiform clouds. This is winter forms of precipitation. Steady rain, sleet, freezing rain, snow. That's typical in the winter. We're now coming into April where we experience more showery precipitation. That would be from cumuliform clouds. It is cumulus clouds that produce hail. So if I move me out of the way and we look here, we can see that what hail is all about is you have rain droplets in the lower part of a cumulonimbus cloud that get pushed upward and cycle through these upper layers of the cloud. Well, even if it's 90 degrees out in the middle of summer, you go up vertically high enough, there is a freezing layer. That freezing layer in New Jersey in the middle of summer might be around 15,000 feet. So that means that any water droplets that get pushed above 15,000 feet freeze. And when they freeze into ice pellets, kind of like sleet, but when they begin to cycle and cycle and cycle, they grow and grow and grow into a hailstone. So the process is completely different. So even if the hailstone in New Jersey lands and is a tiny pellet, we don't call it sleet, we call it hail. Okay, big difference. Hail is a spring and summer phenomenon. You don't get it in winter. Why? Because you don't get cumulonimbus clouds in winter. All right? Whereas in the winter, you have more stratiform clouds, the low gray sky for the entire day, and that's when you'll see sleet. So when you see sleet or think sleet, think winter, think stratiform clouds. When you think hail, think spring and summer, think cumuliform clouds, like you see off to the side of the page here, off to, I guess, what would be my right. Okay. Difference between freezing rain and sleet, number 18, covered already. How hail might form in a cumulonimbus cloud. You can see that in the diagram. Read about it on this page. Hail more common in summer than winter. Well, remember, cumulus clouds, cumuliform clouds, cumulonimbus clouds are more common in the spring and summer. Why? The heating is more intense. All right? You did a unit on seasons for a reason. According to what we know about seasons, when the sun's higher in the sky, and when is the highest point? June 21. That's when the intensity is greatest. So when the intensity is increasing in April and May, that's when you see these vertically built up clouds. And as a matter of fact, what also helps that process is the presence of still cold air, which can occur in March, April, and May, not so much in June and July anymore. And that tends to kind of give, cold air comes in near the ground and gives a lift to the warm air, pushing it higher and higher. So when you think about severe weather season, it's going to be in March, April, and May. And it's also going to be in the middle of the United States. Why? Remember what I said earlier, that the middle of the United States is that battleground between polar air to the north and tropical air to the south. When is it most pronounced? Right now, spring. Okay. So, and again, watch this video over and over again so you really get the ideas that I'm trying to drive home. All right, Doppler radar. Doppler radar very simply shows movement. All right, and Doppler radar is incredibly valuable for meteorologists. If I do a quick Google search for Doppler radar, you'll find tons of images, but looks like the first hit shows you National Weather Service Doppler radar sites. You can find all kinds of great information about this, and it is most valuable in the middle of the country where severe weather is most likely to occur. So I encourage you, do some reading and do some research on Doppler radar. Number 2 in the questions for thought, warm tropical cumulus clouds produce more precip. Remember, warm air can hold more moisture than cold air. So when it condenses, there's more water droplets to produce precipitation when they coalesce together. every day in summer, number 6, a blizzard occurs over the Great Plains. That's not exactly correct, but understand the point. When we talk about these cumuliform clouds, again, 90-95 degrees at the ground, it is 30 or 20 or 10 degrees Fahrenheit at elevation. So yeah, you've got, I don't want to use a blizzard term, the author is being provocative there, but he's trying to get you the idea to think about that even here in Florida where I am, you get up around 20, 30,000 feet, it's below freezing. All right. Recent snowstorm in Denver, and east of there, little if any precipitation. Remember we talked about the rain shadow effect, or the sloping over a mountain? Well, look at this. Here's Denver, and east of Denver we go from brown to green, is downsloping. Well, that downsloping air is going to warm and quote-unquote dry because it'll be further from the dew point, meaning the clouds have a hard time forming. So a snowstorm in Denver that might be a blizzard up in the mountains, because Denver is what we call the Front Range, well, you get east of there and you're into the high desert and then into Kansas, the Great Plains, where precipitation is much more sparse than in the mountains, because in the mountains it occurs based on the air being forced upward. Number 11, Albany, New York, 10 degrees Fahrenheit. I've experienced this, some of you have too. It's freezing rain or sleet. Well, why? Warm air aloft. Remember, proximity to the Atlantic. The Atlantic has a pronounced effect all the way up into northern New England. Some of the most severe ice storms to occur on this planet have occurred in northern Vermont and in southeastern Quebec. Do a Google search on them. You'll find some amazing events have occurred in the past. 13, major snowstorm. This is just a matter of technicalities. When it snows, enough snow that accumulates will begin to compact. So what the National Weather Service says is every hour you got to clean off that surface and allow more fresh snow to collect and then measure it. If you allow it all to pile up, it'll compact or blow around and you'll never get an accurate reading. Just a small point. Anyway, that's it for Chapter 7. So I hope this has been informative and helpful. Send me some feedback if you think this is helpful, and certainly we'll do it for the remaining work for the remaining of the semester. Take care.